Okay, good morning, everyone. As usual, how did the homework go? Any questions? Put them on the chat. Okay. All right, so we go through 47 and 49. And if anybody else has any questions, please make sure you put them. So in this problem, we have a graph. So I will try to reproduce it the best possible way because it's hard for me to put the book here. So it's gonna go like this. That's my graph. It goes down, it goes up. That's the graph of the function. And the function is f of x equal x sine x. Okay. And the numbers are here. We have a pi. Right here, we have 2 pi. So of course, we have pi over 2, 3 pi over 2. And this region is divided into pieces. So they call this the region R1. They call this region R2. And they call this region R3 and R4. And they give us the area of each region. So the area of R1, so the area here is 1. The area here is a pi minus 1. This area is pi plus 1. And finally, this area is 2 pi minus 1. Okay, so that's the picture we have. And they want us to evaluate the definite integral. And definitely they want us to evaluate it using the geometric interpretation of the definite integral. So and let me remind you that the definite integral, if a function is positive, the definite integral is the area. If f is positive, it gives me the area under the graph. So if it is positive. If it is positive sometimes, negative sometimes, is the area above the x-axis minus the area below the x-axis. And that's really the interpretation that we are going to use in this problem. So let us get going. First question is the integral. From 0 to pi, of the function. The function is x sine x. So that's really my function, x sine x. So that's how we write that, x sine x. That's the integrand. The x represent the little delta x in the Riemann sum. All right, and we're not going to compute those because we don't know really how to compute them. We're not going to even estimate them using Riemann sum. It's tedious. They want us really to use the graph. All right, so from 0 to pi, I go back to my graph. From 0 to pi, from here to here, the function is actually positive. So right here, from 0 to pi, so for x between 0 and pi, the function f, that's what I mean by f, is positive. Oh, my handwriting is not very good here. So what does the integral represent? It represents the area under the graph. So that's represent the area of R1 plus, because it's positive, the area of R2 is the area of this region. 0 and pi, 0, pi. Because always remember, the definite integral is nothing more than you take 0 pi, you split it into pieces, and you add the sum of the area of the rectangle. As you're adding more and more area, you get the whole area under the graph. So the area of R1 is a 1 plus pi minus 1, which is going to give me a pi. Okay. Now, let's do the other one. Integral from 0 to 3 pi over 2. So integral from 0 to 3 pi over 2. Okay, I want you guys to give me the answer. I want you to give me the answer and then we check it out. So that's the picture. It is in front of you. And I want the integral from 0 to 3 pi over 2 of the function. It's equal to what? Okay, I'm looking, I'm reading. I see minus 2. Anybody else? I don't know. I mean, I have to compute it. Okay, let's see if it works. From 0 to pi over 2. First, that's my lower limit, my upper limit. I have to look at it. From 0 and 3 pi over 2, the function is not always positive. It's positive from 0 to pi, and it's negative between pi and 3 pi over 2. So the integral is the area of the region above the x-axis minus the area below the x-axis. Above the x-axis, the area is, of course, 1 plus pi, so that's it, 1 plus pi minus 1, we need it, minus below the x-axis, it means minus pi plus 1. Okay, so this is going to give me what? 1 minus 1 cancel out, so I will have y pi minus 1, which is equal to minus 1. Okay, it's from 0 to 3 pi over 2. All right? Okay, one more. And this is this area above the x minus the area below. This is the book is calling it the net area. Different books call it different names. Some book called the signed area. Some book call this signed area, 1 plus above the x-axis minus below the x-axis. Our book is calling it the net area. All right, I'll give you one more. Integral from 0 to 2 pi. So let me push like this so you guys can see the picture. Integral from 0 to 2 pi of f of x dx. Again, I want the answer from you. Okay. All right, again, I want answers. Please, every one of you try to give me an answer. Not only one or two, the usual student. I'm reading. Okay, I have one. We have to check it. Anybody else? Come on, guys. Anybody else? Okay, analyze it. From 0 to 2 pi, lower limit 0, upper limit 2 pi. So I have to compute this definite integral. So between 0 and pi, my function is positive. And between pi and 2 pi, my function is negative. So it's the area above the x-axis minus the area below the x-axis. Above the x-axis I have, so area above the x minus area below. Okay. Above the x-axis, we've done it twice so far, it's 1 plus pi minus 1. Minus the area below the x-axis. It means the area of R3 plus the area of R4. It means pi plus 1 plus 2 pi minus 1. So fine, it's going to give me a pi from here and pi, 3 pi, which is equal to minus 2 pi. Okay. And that's it. I mean, and one more, I actually but I want you guys to answer. What if I take the integral from pi to 3 pi over 2 of x sine x dx? Okay, pi to 3 pi over 2. Quick, I would like an answer. Let me do it this way. So I want the integral from pi to 3 pi over 2, x sine x. Okay. Yes, the answer to the question in the chat is yes. But I want the answer to the question I'm asking. Okay, somebody is telling me it's minus pi plus 1. Is it correct? Absolutely. From pi to 3 pi over 2, my function is negative, totally negative. It means it's minus this area. Okay, so that's the interpretation of the definite integral. All right, any other questions about the homework? Very good. So today, at the beginning, we're going to have a little bit of notation, and then slowly, we're going to see the property of the definite integral and usually how to compute them beside estimating them. Okay, so let us see. So the definite integral is defined to be, and it's so important that you kind of internalize the definition, because the beginning of 164, it will be always this sum in front of you. So the definite is defined to be the Riemann sum. You can take left, right, midpoint, it doesn't matter. So you take the interval AB, you split it into pieces, you compute sum of this 4, and the idea is that the more sum you take, the more subdivisions you take, it means the more n is represent the number of subdivisions, the better approximation. So this is equal to that. So I'm taking right Riemann sum. You can take left or midpoint, and then you ask yourself what happened when n goes to infinity. Okay, so that's our definition of Riemann sum. I could have taken here, if you want xi star, it means I can take the midpoint. So I can take any point really I want. It doesn't really matter. They all give me the same value. So for example, I want to write a function. So example 1. Express the following integral as limit of Riemann sum. Express the following integrals as limit of Riemann sum. Pick the one you want. So let us say it's limit of left Riemann sum. Actually, yeah, left Riemann sum. Okay. So suppose I tell you integral from 1 to 2 of x squared plus 1 dx. What do I mean by my question? Express the integral as limit of Riemann sum. It means that what is this definite integral is about? So this definite integral, the way we estimated it, so that's from 1 to 2. So basically, what's this definite integral? That's really what it is. You subdivide, you add the sum of those area of this rectangle because this function is positive, and you take more and more subdivision. But so how are we going to write it as a limit? The limit we write in the following way. It's sigma from 0 to n minus 1, because I'm writing the left, of quantity of the 4. This is my function f. This is my f. F of xi, then I have substitute f of xi by its value. F of xi times the delta x, where this delta x is 2 minus 1 over n. So we compute those sum for larger and larger n, and then we take the limit as n tends to infinity. But now I want to substitute f of xi by its value. So that's going to give me the limit as n tends to infinity of, what's f of xi? F of xi is the following. Instead of x, it's xi squared, that's what I mean, plus 1 times delta x. That's what I mean by express it as a limit of Riemann sum. Because since I want the left one, I go from 0 to n minus 1. Okay. All right, we're gonna do 2 more. I mean, quite a bit, so you get used to this kind of notation. Now I want, let us say, write Riemann for the following. Okay, so it's simple, but it's crucial. Suppose I give you the integral from, for example, from 0 to pi over 2, let us say sine x dx. Okay. Now I want to write it in the same way, this way. Now I want you, I don't see you, I know that. I want you to write it by yourself. I'll give you like half a minute to write it on a piece of paper for yourself and then check if you're writing it correctly, because a lot of times students mess up in the writing. So I want you to try it, give yourself 30 seconds, do it, and then I'll write it myself and see if you are getting the same answers. But please do it, even though I don't see you. So I want it to be written this way. Be careful, where's the n? Where is the n? What's really the what's going on? Okay. I'm going to write it and check yourself. That's the function, but we evaluate it at those endpoints. So that's what I mean by sine xi. It means you evaluate the sine at the endpoint. You multiply them by the little delta x. And then you take the sum. If I want to write, it means you're taking from 1 to n. And then that's really that's the estimate. So when you take n equal to 5, 6, 7, that we're estimating. But to get the actual value, we have to take larger and larger value of n. And now let's take the limit. And that's where the limit is important. And we take the limit of what? We take the limit when the number of subdivision become very large. Okay, that's really what n is. Now this delta x here really is, so I'm going to rewrite it also by substituting delta x by its value. So that's the limit of the following. Sine the xi, I equal 1 to n. And the delta x actually, delta x is, every time the delta x is the b minus a, that's the b minus the a divided by the number of subdivision. So sometimes we see, instead of delta x, we see pi over 2n. That's really represent the delta x. That's really my delta x here. That's my delta x. And it's the limit. The limit of what? The limit as the number of subdivision goes to infinity. That's what the limit is. Now we're going to go backward. It means I'll give you the limit and you write the integral. I'll give you the limit and you write the integral. Okay, so let's do that. So now the question is, identify f, and express the limit as a definite integral. Okay, so it's just matching things. So I'm going to write the following. It's not really hard at all. So sigma I equal 1 to n of the following. Delta x of 4 xi squared plus xi, and the limit as n tends to infinity of this sum on the interval. So I'm going to give you the interval of 1, 5. So for you, it means that I'm taking the interval 1, 5. That's the interval I'm taking. I'm subdividing it into pieces, and I'm computing the sum for larger and larger n. So that's the interval I am actually subdividing. So I want this to be written as a definite integral. So in my mind, that's what I'm doing. That's in my mind. I'm taking the interval 1 and 5. And I'm subdividing it into pieces. And I'm taking those sums for larger and larger n. So the question is, identify your f and express the limit as a definite integral. I'm not saying it's hard at all, but it's important. That's what I'm saying. Okay, what is the function here? What is the function f that I am talking about? So I want to write this as the integral of a certain function f of x dx. What is f in this scenario? Please write it in front of you. Just identify f. What's playing the role of f in this picture? That's my f. That's the kind of the sum. So my f here is the 4. There is no more I anymore because that's what's playing the role of my function f. And my interval is from 1 to 5. So I'm taking those sums, which means if I tell you evaluate the sum, what I mean is you take the interval from 1 to 5, split it into 10 interval, and then compute. Then split into 100 interval and compute. And this is exactly what the definite integral is. Another example along the same line. And then I have to make a comment because the book is writing this in a different format that I am. But I have to change something in the book. So suppose now I write that. It's the same idea. And let me use xi star. For us, star means the midpoint because sine xi star delta x I equal 1 to n. And the interval that I'm splitting is 0, let us say pi. Okay. So when I read something like this, I have to visualize in something in my head so I know what we're talking about. So when I read something like this, it means I read that we have the interval 0 pi. We're going to split this into pieces. And I'm computing the sum. That's what the sum of those quantity. So it means this is going to be my f, and this is my delta x. And because I put x star, it means I'm evaluating using the midpoint to compute those sums. So I'm just basically graphing this function, which is we have the graph from the book. And then that's really what I am doing in this problem. That's really what I am doing. That's function and value. But which function I'm working with, that's the function that I am working with. Okay, so this is in terms of integral, become the integral from 0 to pi. That's what's played the role of the function x. So we don't write xi anymore in this scenario, times dx. Okay, and so that's how we identify. So if you have the sum, the limit of Riemann sum, and we go backward and rewrite as definite integral. Okay. Now, a comments about the book, because you're going to have homework along those lines, and the book uses a different notation than I am using, but the notation I use, I think, is, I don't know, for me, it's more helpful to the student. Okay, in the book, they have something called limit as delta go to 0. I mean, it is absolutely, that's very correct, is mathematically extremely rigorous, but in your homework, don't worry about that. No, you guys don't worry. Substitute this when n goes to infinity. So even if you read it like this, you guys read it, n goes to infinity, where n is the number of subdivision. All right, so you're gonna have these problems. I'm gonna assign a lot. So when you have delta go to 0, don't worry about delta. Substitute with n goes to infinity. And then the rest will be exactly the same. Okay, and the delta xk, don't worry about it. Rewrite it as delta x. Rewrite it as delta x. All right, so that's the comment about the homework. Okay. Now we're going to see, so that's the definition. Now we're going to see some of the properties of the definite integral. And tomorrow we're going to start basically evaluating those definite integrals. So let us see the properties of definite integral. Okay, property of definite integral. First, right? Suppose I see integral from a to a, integral from a to a of f of x dx. Okay, let's see, this is equal to 1. So the upper limit and the lower limit, they are exactly the same. So what is this integral? All right, if I think about the definition as the integral being the limit of the Riemann sum, my delta x in this case is going to be equal to what?
0.
0. Exactly. Because the upper limit, the lower limit are the same. It means my delta x is equal to 0. It means I'm adding 0 plus 0 plus 0 to each other. So the integral here is actually equal to 0. Okay, so those are integral you will encounter. You know, sometimes have a to a. Okay, what does this mean? This is 0. And the reasoning I give it to you is that because the delta x here is equal to 0. Okay, now this one is a little bit more confusing. Every time we wrote integral from a to b of f of x dx, and the only way, the meaning we gave it is we took the interval from a to b and we did what we did. We took the sum of the net area basically. But in all those, we definitely a has to be less than b for this actually to make sense for us, I mean, graphically. Now, sometimes we're going to encounter a problem where the upper limit, so where the lower limit is larger than the upper limit. So from 4 to 1 of f of x dx. Okay, from 4 to 1 f of x dx. So what does this actually equal to what? I mean, one reason I can give you is that in this case, the delta x would be 1 minus 4 over n. That would be 1 delta x. It means minus 3 over n. So the delta x here would be sigma, if you want, f of the xi times minus 3 over n. Means if I take the minus out, it will be sigma f of xi times the 3 over n. So in other words, the integral from b to a of f of x dx is minus the integral from a to b of f of x dx. So as I said, sometimes you will encounter situation, and it's important that encounter situation where the lower limit is larger than the upper limit. And the question is, what does this mean? Because the way we define definite integral, it doesn't really make sense. So what it means, this is minus the integral from a to b. And one reason is that mathematically, the reason we give, because in this scenario, the delta x would be a minus b over n. However, in this scenario, it's b minus a. So there is a difference of a minus sign. So that's the second property. Again,
I have a question.
Of course.
So it will go back to being a to b once you put the negative sign in front of it?
Yes.
Okay.
Yes, absolutely. So for example, integral from 4 to 1 of f of x dx is minus from 1 to 4. That's what I mean. That clear? That's really what this means. So when you switch the limit, you add a negative sign to it. All right? Now, other properties. If you have two functions, f and g, and that's a sum, crucial. It's like in the indefinite integral, we can break up the sum. A sum could be broken, as in the indefinite integral, the product can never be broken, plus the integral from a to b of g of x dx. Okay, that's a sum, crucial. We cannot break a product. Other properties. Suppose I have a constant, so c is constant. It means it doesn't depend on x. Then the integral from a to b of the constant c times f of x dx. The constant could be pulled out. C times the integral of f of x dx. Okay. Now, the last property is the following. The last property of the definite integral is the following. Let me elaborate it first. And I will write it. I'm going to tell you something and tell me if it makes sense. Okay, don't write. So suppose I have C, at least I'm going to do it between two numbers, A and B. Okay? And suppose I have positive. Okay, for now. Okay. Then does this make sense? So I'm giving you a very simple scenario, because the hard scenario we have to accept it. Does this make sense? Can anybody give me kind of a geometric reason for that? In those, under those restrictions. Think graphically. I'm putting a lot of restriction on my problem. Can anybody give me a reason for that, a graphical interpretation? Why can we break things this way? You can speak up, you don't have to write, just speak up. If anything, anybody can see it, speak up.
It makes sense. I don't know how to put it to words.
Try your best.
I'm kind of thinking of like substituting B, C, and A for 3, 2, and 1, like just as an example. But like, so like B, the second one is B, C to B. As B would be 3 and C would be 2.
Okay.
You subtract, that would be 1. I don't think I'm explaining it right. Actually,
Anybody else?
I'm confused.
It's okay. Don't worry. Anybody else? I don't even know who's talking, so don't worry about anything you guys say. Okay? So, anybody can give me a graphical interpretation of it. I mean, use the geometric interpretation of the integral.
I mean, essentially it's saying that if you add the region between A and C to the region between C and B, it's the same as the region between A and B.
Right. But the area of the region, you mean?
Right.
Right. Yeah. Let me explain what your classmate said. Okay, that's why I put a lot of restrictions, so you guys can see it, at least in this case. So this is A and this is B. okay? And that's my function. And in this particular scenario, I took f positive. Okay, that's so what's this integral in this particular scenario that I told you don't write it yet. In this particular scenario, the integral from a to b represent the area from here to here. That's my graphical interpretation. Okay, now c is somewhere in between. I don't know where. That's my c. And what does this represent? Integral from a to c. That's a to c. That's my c. The integral from a to c represent the area of this region. Integral from c to b represent the area of this, supposed to be purple. Yeah, kind of. It's supposed to be purple from c to b. So what I'm saying is that the area between a and b, which is this definite integral, is the area between a and c plus the area from c to b. And that's really it. So this is this area, that is that area, and this big integral is the sum of the area. So that's the graphical interpretation of that under this restriction. The restrictions are important. Okay, so I want you to see this. I want you always a little bit to think not only in terms of, you know, the symbolism. I want you to interact with the symbolism a little bit. Now, the hardest part is that this equality hold even if c is not between a and b, even if f is not positive or negative. And that's a little bit harder. We're going to accept that, but it makes a lot of sense under the restriction I put right there. So even if it's whole, whether those are hold or not, but when they hold, it's very easy to visualize it geometrically. So the last property is the following. It tells me that I can split the integral. Integral from a to b of f of x dx can be split into the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So we can split this integral. What you have to be careful is that the upper limit here should coincide with this lower limit. That's really what matters. We cannot just split it anywhere we want. This upper should coincide with this lower limit. So these are the basic properties of definite integral. So let us just have a very tiny exercise, nothing hard at all. So let us do the following practice problem. Okay. So let us say you are given very simple integral from 1 to 5 of f of x dx to be 12, and the integral from 1 to 5 of g of x dx equal to 2. Okay, so I have two functions, I'm giving you those. And the question is, find the integral from 1 to 5 of 3 f of x minus 4g of x. Okay. All right. Is this easy or hard? So we're going to use the properties that I mentioned to be able to do it. Since this is a minus, it's not a product, so we can split this integral this way, minus that. And that's definite integral from 1 to 5 equal. 3 is a constant, I can pull it out. Only constant can be pulled out. And this is a constant. Okay. Now we use correct property, and finally that 3 times 12 minus 4 times 2, which is going to give me 36 minus 8, which is going to give me, we take 8, it's going to give me 28. Okay, so just using the properties verbatim. Problem number 2. This one I want you to give it to me to answer. And number 2, we have the following. Suppose I give you given the following. Integral from 1 to 5 of f of x dx equal to 12. And integral from 4 to 5 of f of x dx. So I have one function, I'm going to give you those equal to 3. And my question is find the integral from 1 to 4 of f of x dx. Okay, so you guys have a minute to do it. Use the property that I talked about. I don't see any answers. Anybody? Okay, and now I'm getting answers, lots of them. Okay, absolutely correct. So let us see how to do that. So I don't know how you guys did it, but one way to do it is we see 1, 5, we see 4, 5, 1, 4. So one way we say, okay, the integral from 1 to 5 is the integral from 1 to 4 plus the integral from 4 to 5. And that's the property we've talked about. Upper limit here is the lower limit here. So now we're done. This is 12. And this is what I'm asking for. And this is 3. Okay, now I solve for it, so my integral is equal to 9. Okay, so these are the property of the integral. Now, I'm going to ask you several questions. I mean, not several questions, some questions. Just question number 1. Okay. I'm going to write 2 things on the board. I'm going to write integral from A to B f of x dx. And I'm going to write integral from A to B of f of u du, for example. Questions, is those equal? Yes or no? And why? Okay. So I read one question, which is equal. Equal, absolutely correct. And why they are really equal?
Because it's just a different integer. Not integer, but
No, please.
no, x and u, they're just the same, they're just placeholders.
Right, it's just a placeholder. It doesn't really matter because both of them, it's the same function, right? If you think graphically, both of them represent the same thing. This one represents, so that's my function, whether you call the input x, u, whatever under the sun, I don't really care. Both represent the same thing, which is this area. Both of them represent exactly the same thing, which is the net area. Okay, so whether I use x, dx, u, du, it doesn't really matter as long as my upper limit and my lower limit are exactly the same. This is really doesn't matter at all. Okay, Now, example number 2, now question number 2. And suppose I tell you, give me example at the best you can of a function f such that the integral from, let us say, -4 to 4 of f of x dx is equal to 0. And f is not 0. So f is not a 0 function. Don't tell me take f equal to 0. We can think of a function such that the integral is equal to 0, but the function is not 0. Anybody? X cube, everybody y equal x. Very nice. I'm having all kind of correct answer. So let me say one of your classmates is just telling me, okay, take off x equal x cube. Okay, let's see geometrically why they make sense. This is f of x equal x cube. Okay, this is -4 and this is 4. Okay, so this is 4 and -4. Now we know x cube is symmetric. Okay, x cube is definitely have a symmetry. It means this area and this area, those are equal area, not equal. They are equal area. And now what does the integral represent? The integral represents, so if I call this R1 and I call this R2, so the integral from -4 is minus the area of R1, because that's below the x-axis, plus the area of R2. But area of R1, area of R2 are equal to each other. That's going to give me the integral is equal to 0. Okay, so that's an example of those functions. All right, so for now we defined the definite integral. We define definite integral, which is a number. Remember the definite integral, this is a number because it's just the signed area. And then we define in the previous section something very different. We define what we call, so that's a definite integral. And then we define before something we called the indefinite integral. The indefinite integral. And let us remember, what's the indefinite integral? Because it's been a weeks. It was before Thanksgiving when we talked about that. The indefinite integral is, or in other words, is the antiderivative. So the indefinite integral is a function whose derivative is f of x. Okay, they are very different, absolutely different. This is a number that represents limit of Riemann sum, and this is actually a function. So let us remember, it's very good for you to basically review that for tomorrow, because I'm going to need that tomorrow. So let's remember. So for example, antiderivative of x dx is a half x squared plus c. Okay, that's really just to remind you. And so the big question tomorrow is going to be, which is we're going to call it the fundamental theorem of calculus, which is actually going to relate those two. How are those two related? Okay, so on the surface, no relationship between those two concepts. The first is a number, which is limit of Riemann sum. The second is a function. So remember, this is a number, and this here is a function because it depends on x. It's a function. It's not really a number. And the fundamental theorem of calculus is going to be this theorem that is going to build a relationship between those two. And it's going to be a very powerful tool. It's going to provide us with an extremely powerful tool, not definition. It's an extremely powerful tool to evaluate those definite integral without having to compute limit of Riemann sum. A lot of times. Sometimes it's impossible. We have to compute the limit. But sometimes we have a tool called the fundamental theorem of calculus, which is going to allow us to compute those definite integral. And that will be what we're going to be doing tomorrow and later on. Okay. Any questions before we finish? Now, of course, you guys are wondering about the exam, the final exam. A few words, the final exam will cover everything we've done so far. If you want to review, I mean, even if I put a review on Brightspace, my review, I tell you ahead of time what's going to be. My review is going to be the review 1 I gave you, review 2 I gave you, review 3 I gave you. That's what's going to be exactly. So I'm just going to put them in one file.
Professor, can I make an announcement?
Oh, sorry, Carlos. Yes.
So about the review, PNW is going to be holding what we call study cram jams sometime next week, and there will be like a cumulative review, like 2-hour sessions, sometime in the evening, so more people can go to them. But if you would like, if anyone in this class would like to, if we would like to have one for this class, then I will post a link to a Google form so you can fill out like what time of day works best next week. And then we'll have one, and you can join, and then we'll just review. And so, yeah, if anyone would like, I'll post it in the link here and also on Brightspace.
Just post it. Post it on Brightspace, Carlos.
Okay.
Okay, just post it on Brightspace, and hopefully a lot of them can come. Okay, so the final exam will be comprehensive. It means everything will be on the final exam. If you want to start reviewing, if you have the time, you can just start. So you have a lot of things. You have all your exams, which are absolutely crucial. I gave you 3 exams. Go over each one of them and the quizzes. And you want more reviews, start review 1, review 2, review 3. So that's what will be the review. And the only thing I will add to review 1, 2, and 3 is what I'm doing right now. So more integral, more definite integral, stuff along those lines. Okay. Any question before we let you go? Okay, please do your homework on my lab. Please do your homework. All right. If you guys have any extra questions, you can come to my office hours. All right. Bye-bye for now.